Hey yo, what's up? How's everybody doing? This is Mr. G, and we're going to talk about constant rate of change, and more importantly, we're actually going to really talk about proportional relationships in this video. If you've not watched the 4.1 video, make sure you watch that one first, because I will assume that you know how to use that information, and you all know and you know the information from that video. So all right, let's get after it. So a couple key terms here again. So we had to talk about rate of change, proportional relationships, and just proportions. So first, let's start with proportions. Proportions are when we have two rates or two ratios that are equivalent. Okay, so when we're looking at proportional relationships, when we're looking at proportions, we're really looking at fractions. Okay, and proportions is when they're equivalent fractions. When they're proportional, that means they're equivalent. So, for example, we use proportional relationships and proportions a lot with cooking, for example. So let's say I'm making a batch of cookies, and that batch of cookies was 2 cups of sugar for every 1 batch of cookie. Well, let's say I wanted to make 2 batches of cookies. Okay, well, if I want to make 2 batches of cookies, I want to make sure my sugar is still proportional per batch of cookie, because we don't want to change. If we're changing the recipe a little bit by making more cookies, we want to make sure everything stays proportional so it tastes the same. So if I were to make 2 batches of cookies, I would just multiply everything by 2, and I would have 4 cups for 2 batches. These are proportional because they are equivalent. Okay, 4 cups of sugar for 2 batches of cookies is equivalent to 2 cups of sugar for 1 batch of cookies. These are equivalent fractions. Okay, they are equivalent ratios. Ratios when we're comparing 2 quantities with one another. Now, we're going to talk about how to determine if something is a proportional relationship, and really it's going to be by making sure that the rate of change is constant. Okay, so rate of change is how fast or how much something is changing. So, let's look at what I'm talking about here. So, this is a key point right here. To determine if something is proportional, we want to find the unit rate by doing y divided by x. So here I have a table, and I have a word problem here. So Callie earns money by dog sitting. So this is how much money, by how many days Callie dog sits, this is how much money she earns. We want to determine, is this a proportional relationship? Meaning, is her cost the exact same depending on how many days you use her services? Because sometimes with some promotions and with some businesses, maybe the first 4 days are the same rate, but then that 5th day you get a discount for using it a 5th day. So that's what we're talking about. Is she charging the same amount no matter what? If she is, that means it's a proportional relationship because she has a constant rate of change. If she is not charging the same amount each day, then it is not a proportional relationship. Here's how we do that determination. We do y divided by x. So this is our formula that we use. Y divided by x. Very similar to finding the unit rate. So if I look at my table here, one thing that's a little bit confusing here is our input's always on the top and our output's always in the bottom. So when I do my division, I'm really doing the bottom divided by the top. So I want to say, okay, well, what's my unit rate? If one day she earns $16, that means she earns $16 per day. So $16 per 1 day. So when I divide 16 by 1, I get 16. So that's her unit rate. So if this is a proportional relationship and she charges the same amount, I should get 16 for every single division problem on this table. So what I mean, again, so if I set this up as y divided by x, I got to flip these. So if she made $32 in 2 days, what was her going rate? Well, I would do 32 divided by 2 because this is a fraction, and I would find the unit rate. Well, 32 divided by 2 is 16 over 1. So that means, again, if for 2 days she's still charging $16 per 1 day. So if you use her services for 2 days, you're still paying $16 a day. I'm doing the same thing for this one right here. I'm going to go up here just so I have room. So I have $48 for 3 days. Well, if I do 48 divided by 3, that's going to tell me how much you charge for 1 day if you use her for 3 days. Well, 48 divided by 3 is $16 per 1 day. So again, notice how this is constant. This means we have a constant rate of change so far. No matter what, her rate is $16 per day, no matter how many days you use her. She's not changing her price based on the amount of days. We're going to keep checking to make sure this is true. Y divided by X, so that's 64 divided by 4, because that's $64 per 4 days. Well, 64 divided by 4 is 16. So that's going to give me 16 over 1. Okay, so far, still the same. And then finally, I'm going to check my last one over here. And this one would be $80 per 5 days. I would do 80 divided by 5. I actually need to work out the division. And 80 divided by 5 is $16 per 1 day. So that means that Callie never changes her rate. She has a constant rate of change. Her rate, no matter what, is $16 per day. No matter if she dog sits for 1 day or she dog sits for 5 straight days. So that means this is a proportional relationship because the cost stays the same. It never changes. So this is a proportional relationship because every single time I did y divided by x, I got 16. Now, as soon as I don't get 16, as soon as I get something that's different, it's no longer a proportional relationship. But yes, this is proportional. All right. Now, if something is a proportional relationship, we write the equation in this format here. Y equals whatever that constant of proportionality is that we just got by doing all that division times x. So going back to Callie, we knew Callie was charging $16 per day. That was her constant of proportionality. So the equation would have been y equals 16 times x. We knew that x represented the number of days that you would babysit. Okay, so and that was up here. Our x values were the number of days. And then you would multiply that by 16 to determine your total cost. So my equation for that last one was y equals 16x. If a relationship is not proportional, you cannot do this. Okay, as of right now, if it's not proportional, this equation does not work. We can't write the equation. Not yet, at least. We'll learn how to later, but right now we can't. Okay, so let's just look at an extra one here. So this shows the distance Allison drove on 1 day of her vacation. We want to know if the relationship between the distance and the amount of time she drove is a proportional relationship. Did she drive at a constant speed? So I'm always going to do, so x is always on top, y is always on the bottom. To determine if it's proportional, I always do y divided by x. So this is set up as 65 divided by 1. This one is 120 divided by 2. This one is 195 divided by 3. I have 220 divided by 4, and then I have 300 divided by 5. I need to see if all of these are equal. If all these are equal, that means she was driving the same amount of distance every hour. If they're not equal, that means she wasn't. She was changing her speed, which means she did not drive at a constant speed, which means it is not a proportional relationship. Oh, 65 divided by 1 is 65. So that's the number I have to get. I have to get 65 each time. 120 divided by 2 is 60. So right away, these are not equivalent. So she did not know. She did not drive at a constant speed. She drove 65 miles in the first hour. She drove 60 miles in her second hour. So therefore, she did not drive at a constant speed. I can stop here. I actually don't need to do 195 divided by 3. I do not need to do 220 divided by 4. And I do not need to do 300 divided by 5. I've already answered the question. Now, if this was 65, then I would need to keep checking these until I make sure they're all 65. And as soon as I get one that's not, my answer is no, not proportional. She did not drive at a constant speed. Okay, and I would also write, she did not drive at a constant speed. She drove 65 miles the first hour, 60 miles the second hour. And that's it. That's all we're doing. And that means there's no equation here. There's no equation. I can't put this in an equation format. Try this one on your own, please. So please hit pause. Try it. Let's see how we do. Okay. Quick math joke for you. How do you make 7 an even number? How do you make 7 an even number? You just remove this S. Boom. Get it? 7, S-E-V-E-N. Take away the S, even. Bam. All right. So here we go. Bell, that's all good. Is the relationship between the cost of cashews and the number of pounds proportional? If so, write the equation. So cost of cashews, number of pounds. So I know here's my Y, here's my X. This is 19 over 2, 2850 over 3, 76 over 8. Those are my 3 division problems that I need to actually check. Okay, so you do actually have to do some division. Now to save us some time, I'm not going to work out each division problem, but if I do 19 divided by 2, I do get 9.5. So the cost was $9.5 per 1 pound. Perfect. So that's the cost of cashews for 2 pounds. Let's see if it stays the same for all of these other ones. And if it stays the same, that means the cost stayed the same. So I would check my division again. This is also 9.5 per 1 pound. If I did 76 divided by 8, I do get $9.50 per 1 pound. So that's the cost. The cost, no matter how many pounds you buy, is $9.50 per pound. So if you buy more weight, they don't give you a discount or anything. So now, if I can write the equation, my answer was 9.5 for every division. So my equation is $9.50 per pound. That X, we know, represents number of pounds. And the Y was the total cost. Okay. That's it. Things to remember. It's always Y divided by X. That is super important. People mix that up all the time. Always Y divided by X. And then my format of my equation is always Y equals K times X, where this is that constant of proportionality, whatever that rate, whatever that unit rate is. Okay, please make sure to try the independent practice. Thank you for watching, you guys. Good Diaz out.